So what is the importance of the test class code coverage and what are the best practices? So what are the best practices while writing the test classes? So we will add more addition to this. So let me know any questions at this moment. So this is a syntax for the test class. So test class is a separate class. The first question is test class is a separate class. We have to define a separate class where you can do the code coverage. And each test class must be defined with @is_test annotation. So we call it as annotation. So this annotation helps you, this annotation helps to the executable controller to identify whether it is a test class or a normal class. If it is either it is test, which means this is a test class. If you don't declare that it is a test, then it identifies as a normal class. And also the test method. So test method is a keyword where you can define the method. So in any test class, to write the code coverage, you must define the test methods. So you can define n number of test methods. There is no limit for it, but make sure test method is a keyword and static is a keyword where you define all the test methods with the static key. So this is the syntax. You just follow this syntax always. And the void means this is again we are not returning any value. In case if we return any value, so you can specify the return type, which type of value that you are returning you can specify here. So this is my unit test is a user defined method, so you can use any name there, and based on your source code this logic depends. So you write the test class code, the business logic based on your source code. So we'll consider a few classes that we already done. I mean, we consider few source classes what we cover in the training, and we do the code coverage. And public class and class name. This is common class name. Suppose, so for example, as per the naming conventions, if your class name is ABC, so better to use the test class name as ABC test, so that it will be more easier to identify which is the source class and which is the test class. That's how we use the naming conventions always. So remember, @is_test is an annotation to declare the test class, which is a separator where you can identify which one is the source and which one is the test class. And what are the best practices while writing the test class? So this is one of the most important intro question. So one is each test method must be declared with the start test and the stop test methods. So when you write the test class, make sure you write that test dot start test and test dot stop test. So what is the purpose of writing? So we'll cover while writing the test classes. So I tell you what are exactly the difference. What makes the difference when you use a test dot start and a stop test. Just remember now. So while writing the test class, make sure start test and the stop test methods. And there should be at least one system dot asset statement statement is required for the test method. At least one system data set statement for a test method. Suppose if you declare one test method, make sure the null check. So this is like a check. So once you wrote the test code, so you can check whether the code is reached the targets or not. So system data set, so it will return the boolean result, and if the condition is true, if you get the expected result, then it will return the true. If you don't get the expected result, then it will return the first kind of null checks we can use in the test class. So there should be at least one system dot asset statement for the test method. So make sure that, and we'll introduce these two now. And in case if you have the private methods, and private is one of the access specifier we can use even in the source classes. So we'll introduce test data test visibility method. So where you can, because if it is a private method we cannot cover, so because the scope is still not alive in the test classes. Only the public methods we can cover, public and global methods we can cover from the test classes. So if it is a private methods are limited to only the particular source classes, and to cover the private methods we use test visible. Test visible is another annotation. So we'll talk about the test visible later. I will show you how can you use that. That is a one way where you can identify the private methods and make sure the more code coverage. And another one is prepare the test data when it is needed. So let's say you in the source class you have the SOQL queries and you have the where filters, where conditions, and the test data must be satisfy the conditions. So let's say you have different if else conditions. So when you have the different if else condition, make sure your test data must be satisfied, both if part and else part. So you have to create three records. So one record for if and another record for else condition. Like you need to prepare the test data. So we'll tell the test data preparation. Prepare the test data as per the SOQL and where filters and if or else conditions. So let me log into the Salesforce. So going to the developer console to write the code. So so these test classes are limited to classes and triggers. So for each class or for each trigger you write, you need to write the test class. So I'm going to open a class. Go to open. So you have the different classes in this organization. Let's start with the basic class, arithmetic calculator. So this is a class we wrote in John 30th. So this is a code. So first thing is just review the code. So remember, so first thing is you need to identify how many circles you have, and you need to understand what is the test data you prepare. So just consider these two things. So one is test data and another one is circle query. So here I don't have any circle queries. When you have the circle queries, then only you require to create the test data. If you don't have the circle query, you need to prepare the test data. So remember, sometimes you need to prepare the test data so when you perform some DML operations. So here I'm not doing any DML operations. So the test class varies from source to source. So based on the source class, we need to write the test class. This test class concept comes by the practice. So when you write the more classes, then you learn more. So starting with the basic class. So this is my source class. So what is the class name? So class name is arithmetic calculator, I would like to write the test class for it. You just copy the class name and create a new class, and before that go to Salesforce, go to arithmetic calculator and check overall code coverage. So here the code coverage is 0%. So this particular class has no code coverage. So now let's say this is a class I would like to deploy from sandbox to the production. So first thing is you need to check the code coverage. In case if you have more than 75% of code coverage, you can deploy. You don't get any deployment errors. So I have zero code coverage. Now I have zero code coverage. I would like to write the test class for it. So create a new class, because always test class, you can write the test class separately from the source. So arithmetic calculator is a source class, and added a test so that I can identify which one is a source and which one is a test. I can easily identify by reading the class name. This is a test class for arithmetic calculator. So make sure the entire organization follows the same naming convention so that it will be more easier for you anytime to identify the source and test classes. So as I told you, so to identify this is a test, use at the rate is a test annotation and define the test method, static test method, and I don't want to return anything, void, and your test method name. My unit test is the test method name, and make sure test dot start test and test dot stop test, because start and stop are the two built-in methods. So start test, so which where the test logic starts from, and the stop test where it stops. So the logic that you write between start and stop test will be considered as a single transaction. So this is a single transaction where all the governing limits are applicable. Suppose if you write outside that start and the stop test, this is another transaction where the governing limits are reconsidered. So let's say you are closer to the governing limits. So for example, you are closer to the governing limits. At the time, you can split the logic into two parts. So one is within the start and stop test, and another one is outside the start and stop test, so that this will be considered two transaction. Sometimes when you are working for an application, if you get 100 circle issue while running the test classes, or if you get any DML issues, then generally we do, so instead of modifying or instead of optimizing the entire logic in the test classes, you can just split the transaction. So because in each transaction governing limits are applicable to transaction level, so we have many governing limits. We can write only 100 SOQL queries, or we can perform 150 DML operations. So these are all the governing limits. And when you have the governing limits, which you get while running the test classes, you can just split the class code so that each because the class code will be split in, the method code will be split into two different transactions, and each transaction has a separate governing limits. That is an advantage of start test and stop test. So here, so it will be applicable to the governing limits. It refreshes the governing limits here, and it won't consider the governing limits when it is consumed in the single for the first transaction. The first transaction, and this is the second transaction. Each transaction has a governing limit, separate governing limit. Now, so this is a common code where you can write always. This is a common syntax. You must implement the 5-6 lines of code for any test class. And this is a variable part. So based on your class name, you can define your test class, and these are the variable parts. So return type can be anything, and the method name can be anything. So these are the user defined methods, right? So rest of the code is the standard syntax. There is no change in the rest of the code. Now, so identify the source code first. So while writing the while writing the test class, you just identify the source. So this is an arithmetic calculator where you are where you have the constructor, where you have one constructor, and you don't have any SOQL queries, and even you don't have any DML statement. Just same simple logic you executed, and you have a method called sum, and you have a method called multiply. So two methods and one constructor, and one and the variables. So variables executes automatically, so no need to pass the parameters to the variables. The variable part or property part are some of the statements which runs by default when you initiate the, so when you run the class, when you initiate the member for the class. So you know the constructor, so constructor runs automatically, so when you load the page or when you create an instance for it. So how do you execute this constructor? So by creating an instance or class variable. In object-oriented programming, the constructor is the first member function, and it executes automatically when you create an instance for the class. I'm creating an instance, so this is the instance declaration, and and it runs the constructor in the source class. So I'm just initiating a constructor. So when you initiate this, it will execute the constructor in the source class. Then what are the methods we have? In object-oriented programming, so using this object instance, we need to call the other methods. So what is a dot? What is a method? The method name is sum. So in case if the method expecting some parameters, you need to pass them. So this is a plain method. So it's a uh, non-parameterized method. So you can just call the method name. What is a dot? What is the other method? So multiply is another method. We just call them. So sum and multiply, there are two methods I have. I'm just executing those methods. So test coverage is nothing but executing each line in the source. So executing each line in the source, which means if you have 10 lines of code in the source, just execute it. Just execute what are all the methods you have from the source. See, in case if you have 10 methods, call all the 10 methods properly. Now I'm done with the test class. I just executed sub method and multiply method by creating a class instance. Save it. So to run the code coverage, here is a run test button. Just click on run test. Success. Go to go to the main class. You can see the blue marked ones are the successfully executed lines. And now go to your main class and refresh the screen. You can see 100% code coverage, means all the nine lines. So it will be considered the semicolon is a separate line. So how many times you have the semicolon, that will be calculated as a line. So all the nine executable statements are ran successfully. So this is how you can do the code coverage. See, I have the 100% code coverage. Now successfully I can deploy this component. Successfully I can deploy this component from this org to, I mean from sandbox org to any other org. Not only sandbox to production, but also from this org to any other organization. So you can simply deploy by writing the test coverage. This is a sample test class I wrote. So let's consider some other so that you can get more idea. So let me know any questions at this moment.